Hey everyone, it's Patrick again. It's been a year plus since the last video, and during that period of time, I've got people comment on my videos, telling me how they've benefited from some of the information. So I'm very appreciative. I think that gives me great satisfaction. Some of you are looking forward for more. I think I've still got a thing or two that we can continue with expressions. It really gives me joy to see that people are actually learning it, keeping up and actually following. So let's continue with whatever we've left. In this video today will be finding out how to set this sine and cosine values to any range of numbers that we want. We know that sine and cosine goes from -1 to +1. How do we set that to some other range? Before all that, let's go over the form for sine and cosine again. Gonna grab that cube. Gonna make it move left and right, so we go to expressions, and again, to remind ourselves, there is a default object, and translate, rotate, and scale has a tx, ty, tz as the short name, rx, ry, rz, and sx, xy, xz respectively for rotate and for scale. So if I type tx equals to 1 and I copy that, and if I duplicate this cube, if I select the first cube, it's p cube 1, and if I paste that when I create, you'll see that when I go to translate x, that updates to pq1.translate x, and the long name equals to 1. So if I go to this second pq2, that's the default object, if I paste that and create, you will see that when I select translate x now, it becomes pq2.translate x.1. So this is one of the quick ways that you can just use the same code and apply it onto that object, and whatever that default object is, it gets that value. If I have to, like for example, like 3 or 4 parts of the same thing, with maybe the second part is 2, and then I'll just change that and create that, and then third part is tx equals to 3, and then I can just paste it. I do not need to type pcube2.tx and then the third cube pcube3.tx, so on and so forth. So that's just some kind of quick way sometimes when I want to save keystrokes and all that. I'm going to delete that. I'm going to delete the expression as well and leave us back to our cube. We know that from the last video. Let's select tx is equals to sine time times 1. So that's the speed of time. My project is set to 24 frames per second, so at 24 frames it's 1.0 second. And then we have the multiplier, which is 1 again. So create. To visualize this, we open up the graph editor, and we must remember to be viewing results. Okay, so that is kind of computed results, or else it'll just show manual keyframes. So with result, we can hit A to frame up the entire range of values across our timeline. In case you didn't know this, we can do alternate shift right mouse button, and when you go left, you can zoom the extents for horizontal in the time axis, and you do alternate shift right button, and when you go up and down, you will zoom in the values axis. Okay, so that gives you great flexibility, and you know that this passage of time is only kind of 1.5 cycles for our sine curve. So if I wanted to pass time to pass quicker, which is also said to be increasing in frequency of the sine function. So if I do 2 and hit edit, you'll see it go about 2 times, 2 cycles, and that makes it predictable. We can visualize it very comfortably. And you know that it goes from -1 to 1. From 0 to 1, right, the magnitude is 1 unit. From 0 to -1, we can say that this entire curve has a magnitude of 2, because it spans from 1 to 0, then to -1, that's a magnitude of 2. So if I want it only to be the magnitude of 1, for example, we can do 0.5 times. So you'll see that it goes from -0.5 to +0.5, and that gives us the magnitude of 1. We want in this video to know how to transpose this value to another value we want, because -1 to +1, it is nice. It is not normalized. Okay, 0 to 1 is usually the standard normalize, where you know that 1 is kind of the top and then 0 is the absolute bottom. In this case, -1 is the absolute bottom. For example, if you are in a shooting game and the scale of your scene is such that it needs to go from one feature of in your terrain to the next feature in your terrain, and that's seldom is -1 to 1. So to make it useful, we need it to go to whatever number we want, maybe -3 to -5, or 30 to 50, and oscillating between those values. We actually need the flexibility to be able to do that. So let me show you the non-math way. So in our node editor, right, open up our library of nodes that we can use. You go to utilities, you go to remap. We kind of like remapping the values from -1 to +1 to, let's do 3 to +3 to +5. Okay, so it means that whatever's -1 here, right, whatever kind of +3 to +5. So we want that red, right, to be +3, and then we want this to be at positive. So we want it to be, that's just awful drawing. Okay, so we want to kind of transpose these, but not just transpose. Let's say we want it to be kind of +3 to +2 to +10, even. Okay, so it means that we actually want it to be 2, 10, and then 2, 10. I'm just giving myself points to hit. So 10, and then 2, and then 10, and then 2. Okay, so that changes the very bottom from -1 to 2, and then the very top of 1.0 to 10.0. Okay, so that changes in range. You can take number 3, so you can have 1, 2, 3 in your keyboard, and you can have different ranges of different states of very compact, and then only connected values, and then number 3 is all the attributes being shown. So if I select this and hit the show input connections, you'll see that we have the expression that's feeding in, and the expression, if I hit number 3, that's the output of the expression, which is the result of our of that expression. So in Maya's node graph, you will see that expressions also have a place in there, and whatever expression is outputting is kind of output 0, and we're feeding it into the translate X. So if I wanted to rearrange it, right, hit tab and then remap. Okay, so this remap value, so color is kind of a vector 3 XYZ RGB. This is at hue, saturation, and value, and then we remap value is probably a single value. Okay, so the input value is I'm hitting number 3 here to expand and show everything, and okay, it should be input value, which is here. Okay, so it could be a color, it could be a single value. So connect that input value. So you can see that nothing has changed when we select this cube. So what's this node saying? It's saying whatever is coming in our value range, which is here, the expression is feeding in, what is the minimum and maximum? We know that the minimum value was -1 and to 1, and what's the output value we want to map it to? So we wanted to, as per our example, we wanted to map it to 2 and 10, right? So the minimum, that's the old minimum, right? Whatever's coming in, and it gets processed, and then whatever's going out. So we want it to be 2, right? So -1 here will be mapped to 2, right? And the +1 will be mapped to 10. So put 10, okay? And then the output value, we're not dealing with color now, we're dealing with values. The output value go into the original x-axis, translate X that was receiving. So do that. Okay, and when now we select this p-cube1, right, you will see that value get mapped from 2 to 10. Okay, so that's Maya's node editor with this remap value that gives us this. Okay, and that's it. When you go and play back this, right, we're pretty close to 10, right? So that's 10. You go to the minimum value. That's kind of the second line on the grid, so that's kind of 2. And then you go to the max. You see 2, 3, 4, 5, 6, 7, 8, 9. At the 10th division on your grid, so that's 10 units, and we could see here it's kind of 9 point something. Okay, and that's close to 2.004 and close to 9.8 plus. Okay, the reason why it doesn't reach 10 exactly is because 10, the value of 10 falls between, oh, we do have an exact value of 10 here. Okay, so sometimes 10 falls between frames, right, from here. Okay, another thing that happens with the graph editor sometimes is that it jumps and frame and try when you hit A, right, it tries to frame up stuff. If I keep hitting A, somehow, you know, it's when there are no manual keyframes involved, it can get hard for Maya to figure out the range of values in vertical axis and horizontal axis. So that's why we need the shift alternate right mouse to range it. And sometimes, right, when we change our input, our setup, our value of range, Maya will try and do that auto frame up, and sometimes it gets it wrong. So and that gets disorienting because suddenly we're looking at another, you know, another area like that sometimes. Okay, so if you don't want this, whatever that the ranges that we set up to jump, what we need to do is go to view, and there is a auto frame. Once you enable auto frame, you can see that it jumped, tries and anticipate interesting things that you want to see. Once you have that, there's an auto frame time, whether it frames up time or not. Turn off, turn on again, you'll see it did the same thing as us hitting A, right? So that's what we don't want. If I'm not selecting this and I turn on auto frame and I select it again, you'll see it frames up like that. Select nothing, select again, you'll see it keeps trying to auto frame for us from object to object. Okay, so most of the time I don't do that. I don't really like to do that, so you can frame it up yourself. But I'm digressing, so I apologize for that. It tends to happen now and then in my videos. So this is the remap value. Remap value is available in Maya from software to software. We may not have this. In Houdini, we have the Vex editor with a fit, right? The value, and then we have old minimum value, old maximum value, and a new minimum value and new maximum value. So again, if I'm not in Houdini, I do not have this function, and I'm crippled a little bit. I'm going to do it the hard way and show you how to do what this node is trying to do in expressions. Okay, so if you're perfectly happy with this way of doing it, you can stop the video now and go on with your life and perhaps wait for my next video. But now we're gonna, you know, embark on the hard way to do things. And it's not really hard way. It's just understanding our math, probably high school level math, of adding, subtracting, and multiplication. So for the intellectually curious, please stick with me, and we'll continue to do this. Right. So let's take away that remap. Okay. So when we do things like that, okay, we kind of leave the remap node here. It's somewhere in the scene actually, but it's not connected and it's not affecting things. So sometimes we do want to leave it lying around, but you know, let me show you. If I clear this, right, I wouldn't know of that remap node. If I select this and say, oh, this is my cube, what's feeding this cube? So I'm asking, right, for input and output. So you see that this cube, right, and an expression is feeding, time is feeding the expression, and the expression is feeding the cube. right? And then the cube shape is feeding, it's connected to the shading group, which gives it the shader and all that. Okay, and we do not see the remap node. Okay, so that's kind of a floating there. How do we know it exists? We can find it from, okay, I don't really know how to do this, but in Hypershade I do. So Hypershade shows me utility nodes, and you can see that remap value. So Hypershade is exactly the same thing. Before Maya had this node editor, everything was done through Hypershade, and I kind of love that. But now node editor refuses to show shading nodes, and shaders refuses to show node editors geometry nodes. So okay, so here under utilities, I can show all the textures, I can show all the utilities, which is kind of the plus minus, divide, remap nodes and all that. So it's a shame I have to come over here to look at all my whatever node there is. So if I select this remap node is floating somewhere, right? So with that selected, if I hit input and output connections, you'll see that, oh yep, starting with that remap node, right? It's not feeding into anything, right? It's not feeding into anything, but something's feeding it. So that's the expression, right? Feeding an output. And for the remap node, it wasn't feeding anything. So if you have no intent of using that ever again, please delete that, or else it'll just kind of be floating around and saved together with your Maya scene, even when it's not feeding anything. So that just bloats your scene. File size, of course, one little remap node is not going to make a very big difference. In probably like 2 KB, or half a megabyte, but it just adds up when you have many of these. So just delete that. And okay, so with the expression show input and output, you'll see that the expression is taking time, because in our expression we did mention time, right? So, and then the expression is feeding pq1, right? So we had time, so it got time into the equation, and then it gets connected to translate x. Okay, so this blue one is just internally how Maya deals with expressions. Perhaps the geometry node needs to send a message back to the expression so that they kind of can interact with each other and know where they are. It's too technical for me, or I haven't tried to read out why this is the case, but that's how Maya has it set up, so not worrying too much about it. So let's get back to what we want to do. Okay, so this, we want -1 to be 2 or 3, right, and +1 to be 10. Okay, there's just 2 to 10. Okay, so let's try to do that same thing. 2 ways that we can do it. Okay, our challenge now is 0 is in the middle, and our magnitude is 2. So what we want to do is to have the magnitude to be 1. The game plan is to the curve to be 0 to 1, 0 to 1. So it's like that. Compress the curve so that it operates between the values of 0 to 1, and then the 0 we can add 2, right? So when we add 2, everything now becomes 2, and then 2 to 10 has a magnitude of 8, so then we multiply by 8. Let's just continue and I'll show you how that's done. So our problem is we want it to -1 to 1, so that's the range, and we want it to be 2 to 10. First of all, we want to know, we know -1 to 1, the magnitude is 2. Okay, it's 2. Right, so 2 to 10, we know the magnitude is 8. How? So now we find out magnitude. Right, how did we know 2 to 10 was a magnitude? So 2 to 10 is our target. Okay, so this is our source, right, the original, so this is our target. So how do we find out magnitude? So you get the larger, okay, after we call that the kind of the maximum, right, value minus the minimum value. So the maximum value is right, is 10, right? The minimum value is 2, so hence we get 8. Okay, so magnitude, we get 8. So the target is a magnitude of 8. So let's just try. So if we can, so it's x, right? In order to make it easier for us, we're going to use variables. So variables are just names that we give a value, a label, so that we can call them up again. So it's a bit like algebra. To make a variable, we need to know the type. A decimal type is a float. So and variable always has this dollar sign in front. So float magnitude. We can do a float, right? Target min, which is 2, right? It needs to finish off with a semicolon. Float target max, okay, is equal to 10. So we know, so float, you need that dollar sign, okay, and then magnitude is, right, is 10 minus 2, we know, but we're just going to use this maximum target minus minimum target. So that's the name for the number that they're storing. I could just use 10 minus 2. Hit edit. Nothing changed because we're just giving a couple of labels to a couple of values, right? So now, if I take this magnitude and times, instead of times 1, right? We know that this is the passage of time, how fast, and what's the frequency of time. But we actually really want it to be kind of 8 units. So when we do the dollar sign magnitude, and okay, and we hit edit, you see that it goes now from -8 to +8. But it's not the magnitude of 8, right? I'm going to go back to 1. It's not the magnitude of 8 because to begin with, it was already a magnitude of 2, and you had -1, right? -1, if you times 8, that's going to be -8. So it ended up as -8. +1, and when I times 8, it's going to end up +8. So overall, because I started with a magnitude of 2, right? When I times 8, it's kind of 16, isn't it? Double of 8. So that's the reason why we want to make it the magnitude of 1. So to make the magnitude of 1, whatever this value is, whatever time is, right? As long as it's times 1, is just going to oscillate between -1 and +1. So to make it 1, there are 2 ways they do exactly the same thing. Okay, so sine, whatever sign that is, right, gives you a -1 to +1. So the first method, okay, to get it to 0 to 1 is divided by 2, or you times 0.5. So you halve that. Before that, the magnitude was 2. When you times 0.5, right, 1 becomes 0.5, right? -1 becomes -0.5. Let's try that. So if I times 0.5, hit edit, you'll see that +5 above 0 and -5. So that's half and half. That gives a magnitude of 1. And after you do all these, you add 0.5. Why do we do that? Because when you add something, right, all the values get pushed upwards by 0.5. Hit edit, right? That's then offset. We push the whatever values it's calculated and evaluated, right, and push it up by a 0.5 constantly. So then we get 0 to 1. Okay, so 0.5 to half, and you add 0.5. So you push half of that curve that was falling below 0 so that it touches 0. That gets you to 0 to 1. You can see that over here, right, there's a multiply and then an add, right? So you see this multiply and then an add. So, you know, mathematics and expression has priority, right? The rules of mathematics tells us that multiplication must be applied first and then the addition. This is my favorite method because we don't need to put any brackets. So what's happening is it will do the multiply first and it will get evaluated first and then the addition gets applied. I didn't need to do this and it will evaluate correctly. Okay, method 1. Method 2 is I push it up first and then I divide. So exactly the same if you think about it. So what I can do is, right, we knew that the magnitude originally was 2, so we push by 2 first. Do the, right, again, natively goes -1 to +1. If I plus it, add 1, right, it pushes everything up. We get it to 0, and then when it's kind of 0 to 2, right? If I divide by 2, it's 0 to 1. So if you see it, it's just kind of 2 sides to the coin. You hit that, I get it back to 0 to 1 again. The only thing is that you plus 1 first, and then you times 0.5. Maybe 1 is just a nicer number to be added to, but you know that when I remove this right? 1 times 0.5 is just going to be applied first, and then you get some strange results in the end. So using this method, right, you need to bracket them so that the addition gets applied first and then multiplication, so you get 0 to 1. So you add 1 and then you times 0.5. And this one, the brackets are mandatory because it wouldn't work otherwise. Here, the brackets are optional. This one will still work correctly if you didn't have the parenthesis. Okay, so sine of time and sine of time. So that gets us to 0.1. And then we can do the target magnitude. So let's say we use this method, and that gets us to 0 to 1. Okay, we can give it yet another value. Okay, sine, we can call it sine normalize. Then finally we can do the tx is equals to sine normalized, right? So nothing has changed. We've just given whatever that is a variable name, and then we just put it here, a variable name, hit edit, right? So you'll see that the values didn't change. It's still going from 0 to 1, but you'll see that it never goes beyond into negative anymore. So 0 to 1. Remember, we said we wanted it to conform to 2 and 10. Let's make 2 to 10 visible. What we need to do is times the magnitude. Okay, when you hit edit, you'll see it goes from 0 to 8 because it was the magnitude of 8, right? So now that it's kind of resting from 0 to 1, when we multiply that, that gets us exactly where that is. And then we need to add it by target min, which is push it up by 2. The target minimum, right, is 2 units. So when you hit that, everything gets pushed up by 2 with the magnitude of 8, and then we reach exactly what we want. Using this, we managed to accomplish what the remap node does. Because this is expressions, right? It needs to be translated or compiled or interpreted, and then the result is performed on the geometry. So it's probably going to be slower than just using the remap node, but there's satisfaction to be able to know that you can do this. Once you know the principle behind that, you can do this on any application. For example, in Nuke compositing software, or Blackmagic Fusion, you want to give a range of the number and kind of fit it into a new range. All you need to do is know the range of the original numbers. We can fit the original range into a new range, to any range. Now that I've got the formula correct, I can do a -2 to 10, and when I do that, hit edit, you'll see it goes from -2 to +10. I can do -2 to 3.56 or something. When I hit edit, you'll see it went from -2 to 3.5 something. Okay, so that works for negative number. So -8 to -3. Doing negative number, it works as well. So hit edit, you see that it goes from -8 to -3. You can do anything, 3.4 to 8.7, and it does everything. It becomes predictable. It's just good to have labeled minimum maximum into this, so that you can just change the minimum and maximum, and the rest will just update themselves correctly. I shall end the video here. Yeah, let me know if you found that this method to be helpful, the way I explain it. So that's the end of the video. In the next video, we will find more versatile use for the sine and cosine curve, and we may layer it with the noise function just to see more use cases. Thanks for watching. If you like it, please like the video and subscribe to my channel. I will see you soon.